Okay, so we're going to talk about how this relates to your normal distribution. Now, you've kind of noticed in your problems already, they said you have to assume that you have a normal distribution. If you don't have a normal distribution, you can't do any of this. If it's skewed at all, we're done. We can't do any of this. So, if a random variable x is normally distributed, and that's what you're going to see, normally distributed, you can find the probability that x will fall within a given interval by calculating the area under the normal curve. Okay, so we know how to look up the z-scores. Now we're going to tie those z-scores in to say, pull your probabilities into. You're going to convert the bound, or the bounds, of the interval to a z-score. That corresponds to that x value. We're going to use your z-score formula. We're going to give it an x. We're going to find your mean, your standard deviation. We're going to give you that x value a z-score. Assign it to that. We're going to determine, do we need to be to the right of it, to the left of it. Your mean is what's in the middle. Your standard deviation is measured away from the mean. So we're just going to take what we've been doing, looking up your z-scores, and apply them to some scenarios. Okay, so let's take a look at one and see what we're talking about. A survey indicates that people use their own computers on an average of 2.4 years before upgrading to a new machine. The standard deviation is 0.5. Remember, this book is a little old. A computer owner is selected at random. Find the probability that he or she will use the computer for less than 2 years. The probability that they will use it for less than 2 years. Assume that the variable x, this should say x, is normally distributed. We need to know this. We need to know that it's normally distributed. The mean is right here. This is the two pieces of information you're going to need. Your mean and your standard deviation. Okay? And I'm on example 1 in your book, so if you want to line it up to that, it's on page 229. Now, here's your 2.4. Here's your standard deviations. In the beginning, I'd like you to write your standard deviations out here, just because we get a better placement for where this is. Your standard deviation is 0.5, so this one goes to 2.9. This one goes to 3.4. This one goes to 3.9. Then we subtract, we go down. We subtract 0.5, 1.9, 1.4, 0.9, 0.9. So now, we can see where our scores are going, right? Where the use is going. We want to know that it's less than 2 years. 2.4 is your middle. 1.9 is over here. 2 falls right inside here somewhere. This goes left to right. So the 2 is right over here somewhere. A little bit more than the 1.9, right? And we want to know, what is the probability that they used it less than 2 years? Less than is the area to the left. Okay? So we want to know, what is this area under your curve? That area under the curve will relate to the probability of someone using the computer less than 2 years. So we use your z-score formula. All you did in the last lesson was look up the z-score. Question? I put the mean up here. Here's your mean. I put the standard deviation.
Where you put the line for the green?
Because this is 1.9 and you want 2. So between 1.9 and 2.4 comes 2. So we can see that it doesn't exactly fall on one of those lines that we know and love. So we have to find, what is the z-score related to this? And then we can find the area under the curve. Now, up to now, you found the area under the curve. So now we're going to put this to our z-score. So we're going to say, take your x value. Notice it's in the negatives. So therefore, when you subtract, you know you're subtracting the smaller number minus the larger number, because you need it to be negative. And your sketch shows you, isn't that a negative number over there between 0 and -1? So we do all that, and we come out with negative 0.80. Now here's where we were yesterday. We looked this up on your table. We want the area to the left, so we looked it up on your table, and it corresponds to 0.2119. Or you do your lower limit is negative 999, do your upper limit at negative 0.80, and you can find it. And there is your area under the curve. Probability is the same as your area. You can even move this to decimal places. It makes probably more sense to look at it as a percent. There's a 21.19% chance that people will keep theirs less than 2 years. Okay? So all we did today was take a scenario, give it the x value, convert that to a z-score, and then do the same thing we did yesterday. If we want to know what the probability is that they used it for more than 3 years, we come here to your 3. Oops, here to your 3. And we put this in your z-score formula. If we want it to the right, what do we do once we look up your z-score? Subtract your area from 1. So we're just applying your z-score formulas to a scenario now. It does make a little bit more sense. I mean, looking up the z-scores, like I told you yesterday, seems kind of pointless. Like, what do I do with this? Once we start using this, you kind of see the need for it, how we use these. Okay, so you guys are going to try this. I want to see a sketch. I want to see your mean. I want to see your standard deviation out there. All right. So let's take a look at this. You have a normal curve. It is normally distributed. It told us that, right? So let's put the mean here. What's the mean? 27. What's the standard deviation? Okay, so 27. Let's go out. This is your 0. Okay, anybody string these out?
I did.
Okay, I'll get the left side from you. I'll get the right side from Anthony. How's that? 28.6. Thank you. 31.8. Joey, what'd you get for this side?
25.4. 23.8.
22.2. Thank you both. Thank you both very much. Now, this kind of gives you a little perspective about where your scores go for this. Now they're measuring miles per gallon. So they want to know right here, will it get more than 31 miles per gallon? This is an x value, you're 31. So they want the probability of being greater than 31. Start with your statement. So when we find the area under the curve, do we want the right or the left? The right. So we're going to plug this into your z-score formula. And 31 falls about here somewhere, right? Right in between here. Somewhere in there. Which is, would the z-score be positive or negative? Positive. So we have to subtract the larger number minus the smaller number. If you forget which way it goes, use the sketch to help you. Over the standard deviation. So anybody come out with a z-score? 2.5? Exactly? Thank you. So we got a z-score of 2.5. Now, we look that up. When we find your area for 2.5, we find it as 0.9938. Does that area look like it could possibly be 99%? So what do? Subtract it from 1. So you subtract it from 1, and you get 0.0062, which is, if we move this over, slightly less than 1%. It's a less than 1% probability that the Ford Focus we select at random actually gets more than 31 miles to the gallon. No, you can leave it as the area. I just want you to, like a lot of kids usually relate to a percent. So if I'm looking at, what's the probability that it will get more than 31 miles to the gallon, it's less than 1%. So say you're going to look for this Ford Focus. Percents are easier to interpret. You can leave this as this answer. This is fine. But if you're interpreting it, then flip it to a percent. Because if you have to interpret this, like, what do you say? This is 0.0062? Like, that kind of doesn't have a good meaning to us. If we want to say less than 1%, that kind of makes more sense to us. Like, if I'm looking for this Ford Focus and I'm going based upon the fact that I'm going to get high mileage, what's the probability that I'll get more than 31? It's small. It's less than 1%. So maybe I don't want to look at it. Maybe I want to look at a hybrid. It is guaranteed to get more than 31 miles a gallon. These are things that the reason why you test these things. Now, I'm going to show you a little trick in your calculator. Go to normal CDF like we did the other one. You know how in normal CDF, if we put the mean in as 0 and the standard deviation in as 1, we found an area for your z-score? Well, we can bypass this entire piece right here and get our answer by using normal CDF. What you're going to do now is use your x value. And therefore, you're going to have to put your mean in and your standard deviation into your normal CDF. So go to your normal CDF. You're going to still use your lower limit, your upper limit. This is an upper limit. So we put our upper limit in as 31. What's your lower limit? Your lower limit as 31. Which second there? Your lower limit is 31, and your upper limit, this is why I always use 999 and negative 999. Most of the times it works for your application. Unless this was in thousands, then you just add a couple more nines. So lower limit 31, upper limit 999. We'll never have more than 999 on here. But now put your mean and your standard deviation in. 27 is your mean, and your standard deviation is 1.6. Now go to paste. Do you get this answer, 0.0062? Kind of nice. It bypasses this whole step. I would like you to know how to do this, though. I'd like you to work this out, check them on your calculator. When you get really comfortable with the fact that we're using your z-score formula, we're looking at the area to the right or to the left, you almost have to know that to put it in your lower boundary, your upper boundary. If this had like 27,000, then you can't use 999. Just make a few more 99999. You use it like that. So this way you kind of keep yourself in the clear. Does it make sense? Okay. All right. So let's try another one. A survey indicates that for each trip to the supermarket, a shopper spends, on the average, of 45 minutes in the supermarket with a standard deviation of 12 minutes. The length of time is normally distributed. They have to tell us that, because if it's not, we can't use our z-scores, and is represented by the variable x. A random shopper enters the store. We want to find the probability that the shopper in the store will be in the store between 24 and 54 minutes. Somehow it looks like I messed that up when I wrote it. Between 24 and 54 minutes. And then we want to find out how many would be expected to be in that time frame if 200 people entered the store. Okay. Once you find out what's the probability that that person will be in the store between 24 and 54 minutes, and we can take your probability and figure out of the 200 how many I expect to be in there. So let's start with your sketch. Here's the middle. This is 45. We're going to add 12 all the way up. Check my math. Okay, we're going to subtract. between 24 and 54 minutes. Somewhere between here and here. We want to know this piece right here. Okay? How do we do a between? Subtract your areas. So therefore, we have to do a z-score for 24, find its area, a z-score for 54, find its area, and subtract them. And then we're going to do them on your calculator with a lower and an upper, and get it real fast. But we're going to do it the other way first. A z-score for 24 and a z-score for 54. Now the z-score for 24 should be positive or negative? Negative, good. So we're going to subtract the smaller number minus the larger number over your standard deviation. Your z-score for 54 should be positive or negative? Positive. See, this helps when you subtract. So the larger minus the smaller. That way you don't even have to remember x minus the mean. You just know because it has to place that way. So for the first one, we're going to get negative 1.75. And for this one, we're going to get positive 0.75. And does this make sense? My negative 1.75 between negative 1 and negative 2? Yeah. And my 0.75 between 0 and 1? Mm-hmm. Now, you're going to look up the areas for both. Yes?
Why do you have to subtract the before, like, the bigger one on that side?
Because on this one, you're in the positive section. Your z-score formula is always x minus the mean. So this is our x value. But what I'm saying is, if you forget which way it goes, use this chart. Because here, for 54, it has to be positive.
Okay.
So I have to subtract the bigger minus the smaller. Here it has to be negative. I have to subtract the smallest minus the larger. So that I still do it that way. I look to see if it's negative or positive, and I know which way to subtract it. I think it's kind of helpful that way. So you're going to find your areas for these guys, and we can rate it like this. The probability that your z-score falls between here and here, or the probability that your x-score falls between here and here. So now, you're going to find your probabilities and subtract them. So here's our answer. This by itself just gives me the area under the curve, which is a good chunk of my curve, right? Isn't it the biggest chunk of that curve? If I want to interpret this, I move this over and I say about 73% chance that a person will walk into my store at random and spend between 24 and 54 minutes. There's a 73% chance. If 200 people now walk into my store, if n is 200, this is the second part, how many do I expect to be in my store?
146.
How'd you get that?
I did 200 times 73%.
Times 73%. Good. And you got 146 people?
146.66.
0.66. So not quite yet 147, right? Not quite yet. Now this is where the rounding gets tricky. If you multiply it by the whole 73.33, or just 73?
I did the whole 73.
Good. Okay, so now, you didn't exactly reach 147 person. So round to 146 on this. If you estimated at 147, it's not a big deal, but you didn't reach that person yet. So now, we know how to find the probability that this will happen. There's a 73% chance that the next person that walks in will spend between 24 and 54 minutes shopping. And if 200 people walk in, I can expect about 146 of them to stay between 24 and 54 minutes. Okay. Now, on your calculator, watch how nice this is. Normal CDF. Here's your lower limit, 24. Your upper limit, 54. Your mean, 45. Your standard deviation, 12. You paste it, and here's your answer. Their rounding's a little bit better because they don't use a table. They have a different algorithm to round. So their rounding is a little bit different than ours. So all this work down here can come from your calculator. You can use either method you like. I still need the sketch. I need the sketch to know that you know what you're doing. And usually, like I said, I get half my class that uses the formula, half my class that likes the calculator. That's up to you. Okay? If you guys are packing up, we got 5 minutes. Any questions on this first? No? Okay. Oh, okay, we didn't do more than 39 minutes. All right. Tomorrow we'll start off with this.